So let's go ahead and use one of those thermochemical equations and combine it with something that we know and love from chapter 3. That is the limiting reactant problem. Okay, so consider this. Calculate the amount of heat produced when 2.6 grams of ethane reacts with 3.58 grams of O2. Now realize, since we're actually giving uh, masses for both of the reactants, one of these is most likely going to be the limiting reagent and the other one is most likely going to be an excess reagent, unless by some miracle they picked just equivalent stoichiometric amounts of each reactant. Recall two things that we're going to need are the molecular weights for both of our reactants. So here we go. Let's go ahead and get to the periodic table. We see that carbon's here, 12.01, and oxygen is 16.00 to 26 figs. And then what's the other thing we need? Oh, no, that's it. And hydrogen is 1.01 to 2 decimal places, not 6 figs, 2 decimal places. So moving back to here, we see for this particular, for ethane, that we are going to have 12.01 times 2, because there are two of them in the formula. And then for the hydrogens, 1.01 times 2. And so that will end up being, what is that, 14.04 grams per mole. And then for O2, it will end up being 36.00, or 32, because it's 16 times 2. 32.00 grams per mole. So we gotta find out which one is the limiting reagent. So we're going to start with what's given for each one, see how much of one of the two products we're going to form, and I'm just going to go ahead and go to water just because it's got a lower number of moles here. So starting with ethane, we're going to get back to my pointer here. We're going to start with 2.60 grams of C2H2. Got to convert that into moles of C2H2, so we use the molar mass right here. I did that completely wrong. That's 12.01 times 2, that's 24, should be 26.04 grams per mole. Let's cut that out. All right. So 26.04 grams per, and we're going to put the 1 mole up here. So the grams will cancel, will be in moles of ethane. Then we've got to convert from moles of ethane into moles of water. So we see that for every 2 C2H2, we get 2 H2O. H2O. These 2's will cancel nicely here and here, so they'll cancel with each other, and the ethane will cancel with that ethane, and will end up being in units of moles of water. So let's go ahead and get out a calculator here, put in our numbers. So we got 2.60 divided by 26.04, and we end up with 0.0998. 0.0998. So 0.0998 mole of H2O. So that's how much water can be formed with this much mass of ethane, assuming we have enough oxygen. But we don't know if oxygen is the limiting reagent or if ethane is, so we got to start with oxygen now. Starting with 3.56 grams of O2. Got to convert that into moles of O2 using the molar mass right there. So it's 32.00 grams per 1 mole. Now we'll convert, our grams will cancel, of course. We'll be in units of moles of oxygen, but we want to be in units of moles of water. And so we use the balanced stoichiometry here. We see that for every 5 moles of oxygen, we get 2 moles of water. So 5O2, 2 H2O. So these don't cancel quite as nicely as it did up here, but we can use our calculator to figure it out anyway. So here we are. All right. Oh, got the wrong thing in the background. There we go, and there we are. Okay. So put in our calculator, 3.56 divided by 32 times 2, because 2 is on the top in that last bit, divided by 5. We end up seeing, oh, that doesn't seem right at all. Let's try that one again. So 3.56 divided by 32 times 2 divided by 5. That seems more reasonable. Okay, so we end up with 0.0445 moles of water. So 0.0445 mole of H2O. So which one's our limiting reactant? If we look at these two numbers, we see that oxygen is producing less water, so oxygen is our limiting reactant. All right, so I stayed in moles right here for the number of moles of water produced, which is kind of nice because we see that there's a direct relationship, molar relationship of moles of this to heat produced. And so if we start with the number of the moles of water that is actually produced, theoretical yield, a mole of H2O. We can convert that using our balanced chemical equation. We see that for every 2 H2O, actually it's 2 mole of H2O, we end up producing negative 2511 kilojoules of energy. All right, so let's go ahead and put it into our calculator. So we put in 0.0445 times 2511. Remember that this is actually a negative value, so we'll have to switch the signs. Divided by 2. That 2 down here. So we end up producing a negative 55.9. So put in here, negative 55.9 kilojoules of energy when this reacts as far as it can go. Remember, oxygen is our limiting reagent, and so when the oxygen runs out, at that point we will have produced this much heat.